L3Harris is one of the few places in the world that can build extremely large spaceborne optics for very precise optical imaging systems.
Companies that have extraordinary large optics production capability, there's only a handful in the world and in a smaller handful in the United States of America. We have hundreds of thousands of square feet of facilities for assembly of large optical components, integration of those components into optical systems, and then we have a full suite of environmental test capabilities, including thermal vac and mechanical testing.
With easier access to space, our customers are coming to us and wanting things to be finished faster and cheaper so that they can get units launched that are functioning much faster.
We have a history at L3Harris of building the best products, the highest performing products, but what we've been focused on in the last 5 years is driving cost and schedule out of those products.
DMU is a really advanced 5-axis machining center. We can do our regular glass grinding on that machine as well as a lot of new functions. It's very capable and high-tech.
Capture range replication is a significant advancement in optical fabrication.
In the past, when you wanted to make a large optic, you would buy a large piece of glass that may be rough cut into a sphere.
And you would continually cut away and grind away at the surface to get to a very, very shiny, reflective, perfectly polished surface. What we do for capture range replication is we instead create a mold and then replicate the surface off of that mold.
So it cuts out a lot of that earlier step and gets us closer to the end quicker.
We found that we can reduce cost and schedule by more than 50%.
At L3Harris, we frequently have to finish optics to nanometer precision, which means if you took the human hair and divided it 10,000 times, that is the amount of error we can accept across the surface.
Ion beam figuring is literally the removal of individual molecules of material from the surface.
The way it works is you actually hit the surface with inert ions. They actually bond to the glass and pull away a molecule at a time.
We have our engineers define what needs to be removed from the surface and drive that mirror to its final performance.
We have invested in development of new materials that allow for rapid production of optics.
We are now bringing in higher stiffness, better structural materials.
So we actually can create a stiffer, lighter, larger, monolithic mirror than we could in the past using glass.
We are fundamentally inventing new technologies to meet the new mission needs. The fact that we have the capability to work both in design space and in manufacturing space with all those materials gives us a great advantage over our competitors and gives us great value to our customers.